niekto už viame alebo sledovali ste hodnicu? Dobre, takže to budeme mať zážitok, že prvýkrát.
We have dug here to see what's happening in the soil under cereal, winter crop, winter cereal here with the wheat, and to see how it works. And it's very important because it's the way the plant is feeding through the roots. So we have to see the root development, and if it can also feed enough the plant to have a good yield, and then to have good food after from that yield. First of all, you can look at the top of the soil. The first horizon you see is very grimly with a lot of small roots. But if you look in detail, you'll see that they are compacted. The pieces are compacted. So we are in a clay soil here, where you see the clay is compact and hard, and it's a first border difficult to cross for the roots. You see there are a lot of roots over there, but under that there are less roots, and you see the soil is quite hard. You can break it, but it's quite difficult. And if you go even down there, it's even harder if it's harder for a knife like that, it's very hard for the roots to go through. When we have dug with the bagger, with the digger, it's you can't see the soil, so you need a knife like that to see the soil structure, and to also to feel it there. And you see that under the very hard soil at the top there is a better structured soil where the root can develop and the fine roots to take the elements. So here it's the soil with a conventional way of handling the soil. It's not it's quite an intensive way. It's not it's quite but it's a normal way to handle the soil with chemicals and fertilizer and pesticide, and we see also the consequence of that problem of that use of the land. There is this compaction is linked directly to the use of heavy materials, and also the lack of humus in the soil, because the humus can prevent these soils to be so hard. They are very useful, the worms, because they bring air in the soil. They do holes, so they bring air in the soil, and the holes can be used also by the roots of the plant to develop. And also the microorganisms can use the lift of these worms to go down the profile or to go up, and so they are very useful for the soil life, and themselves they are eating some soil and making the elements of the soil available by their digestion of the soil. You can take a piece of soil and count how much worms you find in the soil, on which you look and you count. You try to find if there are whole of worms, and you count the whole of the worms which have been through that plate. And here it's very difficult. Well, we counted just a bit before, and we found only four holes of worms. So it's a very very poor quantity of worms. Sure, they didn't like the treatments this soil had, and that's why they are so less numerous. So here we are also in the same type of soil, and you can see globally with always this bed of stones from an old the old place of the river where the river was, with the stones and over it this soil with quite a lot of clay in it, and also a winter crop, a winter cereal. Here it's winter barley, which is quite nice. It's been a bit. Here we are with a complex of microorganisms which are producing very quick humus in the soil, reducing the leaching, and then improving the fertility by developing the clay humus complex and the storage of elements in the clay humus complex, which enables you to get rid of a lot of chemicals, nearly everything. So that means mineral fertilizers and also chemical like pesticides. And you can see that here the level, you find the first level of first horizon of soil is like on the other side, very grimly, very with a lot of hairy roots, very dense in the roots, but it's much more thicker. It's 10 centimeters deep, when the other side was 5 centimeters deep. And when you look at the particle of the soil, it's there. You don't find the compacted clay like in the other side. There is clay anyway, because you can see, and you find also like in the other side compacted horizon here. But this horizon is just between here and there, yeah, because so it's much more thinner than on the other side. And what you can see, it's also that there are a lot of roots which are going through it. Even if it's harder, you can see roots going through it. And if you go a bit more down, you can see even ways where here you can see, for example, a way of. So it was a way of a worm, earthworm, which went through there, and now you see that it's black around, and there is a root taking the way. What's happening? It's the plant does photosynthesis with the light of the sun. The leaves fix the CO2 from the air, the carbon from the air, to build sugars. The sugars go through the plant all along the roots until the end of the root, where the root is growing, and they use these sugars as energy to develop. But the photosynthesis continues to produce these sugars, and even more than what the plant need, and what the plant don't need actually arrives at the end of the root and is produced by the roots. And then around the roots, then there are microorganisms which are developing using these sugars as energy to develop and to multiply, and in exchange they give back the microorganisms, which can be bacteria or fungus or both. Actually, both all together are working in symbiosis with the plant, and they are bringing minerals when the plant brings sugars. And that was what my old teacher from the French University of Agronomy in Paris named the third agricultural revolution, Marcel Moiselier, and he's the specialist of the history of agriculture. So in his mouth it was something very clear. But when you look at that, you can see it's really a revolution, because you use properties of the soil that we, for now, agriculture never used. The first revolution was more the use of more material, the plowing especially, and mechanical, physical revolution. The second was, of course, the chemical revolution with the arrival of the mineral fertilizers and the pesticides. And here we have the third revolution, which is the biological revolution, microbiological revolution, if you want, because it's mainly microorganisms which are doing the work in symbiosis with the plant, of course. What's very interesting too is in that soil, it's evolving towards more humus storage and better fertility. And you can see here very well the plant, the barley, this winter barley is very nice. It has no disease, and it good color, good density, and will promise a very good yield without any. There was no pesticide on that barley. The conventional, it's not an organic farmer, but he didn't use any pesticide, and he didn't use any chemical fertilizer, mineral fertilizers. So you use only organic matter. Here it's digestate with microorganisms, and you will produce like the best farmers around here. So here again we have this plate we prepared to look and to count the worm holes. So the same way, with a small knife you take over the surface, and then you see there are holes there. See, 62 holes in that small, which means it's 1,204 holes of worm per square meter, which is over 10 times more than on the other side. So the density of worms is incredibly higher here. It's clear that the life of the soil is much more developed here, that they can feed so many worms, and that the worms can do so much work.